Um, so this, we just have to just know that the cosine of x is equivalent to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, etc. So 2x means that we're going to plug in 2x in place of x. And notice if we do this, we get 16x to the 4th. 4 factorial is 24. And so if we divide by 8, we get 2 and 3. And so we have C. Okay, so we want to figure out for which values of x that this converges. That's asking for the interval of convergence. We're going to force it to converge by taking the n plus 1 term over the nth term, which is equivalent to multiplying by the reciprocal. And so we get x minus 2, and we're left with the negative 3 down here. And so the absolute value is going to be x minus 2 over 3 needs to be less than 1, so x minus 2 needs to be less than 3. So that means x will be between add 2 and subtract 2, so add 2 to 3, and get 5 and negative 1. When you test the endpoints, so if you plug in a negative 1, you would have negative 3 to the n over and negative 3 to the n. These cancel, and so this diverges because it's the harmonic series. P is 1. If we plug in 5, more than likely it will converge, because a lot of times, not always, but often one endpoint converges and the other doesn't when you have a geometric series, or some form similar to a geometric series, multiplied by a polynomial. So we have 3 to the n, negative 3 to the n, so what happens is you'll just be left with negative 1. And so negative 1 to the n, I can put it in the numerator if I want to. And this is alternating and decreasing, and the limit goes to 0, and so this converges. So our answer is C. Okay, so looking at this, I automatically notice that we're counting by ones, and so hopefully you know that that looks kind of similar to E. So you know it's not this or this. Alright, x squared. If it was just x squared, it would be 1 plus x squared plus x to the 4th plus x to the 6th, etc. And you see that there's a 1 more x. The way you would get 1 more x is by multiplying through by an x. And you would add those exponents, and so you get this. Alright, so the coefficient of x cubed. So we know Taylor series e to the 2x, we have 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. And so if it's 2x is substituted in, we have 2 cubed is 8. 8x cubed over 3 times 2, so that's 4/3. Alright, so this is a little bit tricky. You notice this looks kind of like a geometric series with your r, but you know it's usually written like this, r to the n or r to the n minus 1. So we need to kind of rewrite this and see it's cosine of x cubed to the n, and you would multiply those exponents. So this is our r. And our first term, if I plug in 1, I would just get cosine of x cubed. This would be my first term. And so the sum, which would be the function, the sum of the function would be equal to the first term over 1 minus r. I want to evaluate this at 2 pi over 3. So we want the cosine of 2 pi over 3 cubed, or 1 minus the cosine of 2 pi over 3 cubed. And cosine of 2 pi over 3 is negative 1/2, and so we end up getting negative 1/8 over 1 plus 1/8 because it's minus a negative. So negative 1/8 over 9/8 gives us negative 1/8 times 8 over 9, and so we get negative 1/9. Alright, so kind of just guess and check and see what the r is, and if you notice, we divided by a 3 because this became 3, we need to multiply by 2, so this would become a 4. The sides are alternating, so r would be negative 2/3, and the first term is 9/8, and so we just use the sum formula where we take the first term and put it over 1 minus r. So 9/8 over 5/3 is the same as 9/8 times 3/5, and so we have 27 over 40. Okay, so we just need to evaluate all these derivatives. So f prime of x would be 1/2, 1 plus x to the negative 1/2. F double prime would be negative 1/4, 1 plus x to the negative 3/2. Notice the signs are alternating, we get 3/8, 1 plus x to the negative 5/2. The fourth derivative would be negative 15 over 16, 1 plus x to the negative 7/2. We're evaluating all of these at 0, which is nice because you basically just get the coefficient in each place. Because 1 plus 0 gives you 1, and 1 to any power is 1. And so then you just list out using our, when we say 1, and then plus 1/2 x. And then minus 1/4 x squared over 2 factorial. And then it would be plus 3/8 times x cubed over 3 factorial. And I accidentally went too far here. You can simplify this if you want, or keep it as it is. Notice, do not put that the f of x equals this. It's the polynomial. So you stop when you get to degree 3. Okay, so in this case, they give us a series about x equals 2, so that's the center, and they give you a formula for the derivative, and they give you an initial condition, and it says write the first 4 terms of the general term of the Taylor series for f about x equals 2. So we know that it's going to be f of 2 plus f prime of 2 times x minus 2 plus f double prime of 2 over 2 factorial, x minus 2 squared, etc. I guess I need to do one more. Over 3 factorial times x minus 3 cubed. And so I know that f of 2 is 1. F prime of 2, use this formula right here. So f prime of 2, if n is 1, then we have 2 factorial over 3. F double prime, if that is 2, then I would have 3 factorial over 3 squared. And if I add 3, this would be 4 factorial over 3 to the cubed. Then simplifying this 3 factorial and 2 would cancel to just give you a 3. And this would cancel to just give you a 4. And so if we notice, you're left with n plus 1 times x minus 2 to the n over 3 to the n. Okay, so the radius of convergence, that's when you take the limit as n goes to infinity of the n plus 1 term, so add 1. And then put the reciprocal. And so you're left with x minus 2 and a 3, and the limit of n plus 2 over n plus 1 will be 1. So we have this, so x minus 2 must be less than 3, so our radius is equal to 3. Oops. C, let g be a function satisfying g of 2 is 3, g prime of x is equal to f of x. So that means that the integral of f of x would be equal to g, the antiderivative. And so I need to take the antiderivative of f. This represents f, so I need to take the antiderivative. So that would be x plus 2 over 3 x minus 2 squared over 2 plus 3x minus 2 cubed over squared root of 3. Then it would be plus 4 times x minus 3 to the 4th over 4. And then if you think about the general term, it would be, you add n plus 1 and divide n plus 1, so you have x minus 2 to the n plus 1 over 3 to the n, because the n plus 1s would cancel. And so, and also don't forget Charlie, okay? Now I need to find him. If I plug in 2, I'm supposed to get 3. So if I plug in 2, all of these will zero out. So all of these go to 0. But then you would just have c plus 2 needs to equal 3. And so that means that c must be 1. And so that's where they get that c is equal to 1. Does the Taylor series converge at x equals negative 2? Well, if I find my interval up here, I have x minus 2 less than 3. It would be between negative 3, x minus 2, and 3. So if I add 2, I have negative 1 and 5. And so I might gain an endpoint, but it's not going to go to negative 2. So my answer is no, because it's outside of the interval of convergence, which is from negative 1 to 5. And then, okay, so polynomial, I just need to take derivatives. So f is equal to cosine, so the derivative would be negative 3 sine of 3x plus 3 pi over 4. The second derivative would be negative 9 cosine 3x plus 3 pi over 4. The third derivative would be 27 sine 3x plus 3 pi over 4. And then I'm evaluating all of these when x is 0, and so you're taking the sine of 3 pi over 4 is the square root of 2 over 2. Cosine of 3 pi over 4 is negative square root of 3 over 2, so this would actually end up being positive. And then sine is again positive. Oh, 3 over 4 square root of 2. And so then we just listed out, oh, the cosine of 3 pi over 4, negative square root of 2 over 2. So we have negative square root of 2 over 2 minus the square root of 2 over 2 times x plus 2 times x squared over 2 factorial plus 27 square roots of 2 over 2 times x cubed over 3 factorial. Okay, and then this says, use the Lagrange error to show that the error for 1/6 is less than 1 over 300. So this says that the max for the third degree is going to be the max of the fourth derivative times x minus c, which is 0 to the 4 factorial. So I need to take the fourth derivative. The fourth derivative would be 81 cosine 3x plus 3 pi over 4. And so the max of this would be 81 times 1, because the max of cosine is 1. And so we have 81 over 4 factorial. And so that means that for specifically the remainder at 1/6, times x to the 4th, would be 81 times 1/6 to the 4th, 4 factorial. And so 81 is 3 to the 4th, and this is 3 to the 4th and 2 to the 4th. And so you can see those cancel, and so we have 1 over 4 factorial times 2 to the 4th, and this is equal to 1 over 24 times 16, which is less than 1 over 300. Okay, and so for this one, I just need to take the antiderivative of our function up here. So it'd be negative square root of 2x minus 3 square root of 2 over 2x squared over 2, and then plus 9 square root of 2 over 2x cubed over 3, and I still have that 2 factorial, so this would cancel and I get 3/4, and so that's when we get this. And it says that go from 0 to x, so I should have used t's. Should have really written this out and said the integral of negative square root of 2 over 2 minus 3 square root of 2 over 2t plus 9 over square root of 2 to 2 factorial t squared dt from 0 to x. And so then you get this, you plug in x, and so that's how you get this. Plug in x and plug in 0.